Hello there. So up till now in this chapter, we have talked about arithmetic sequences and arithmetic series. And on the very first day, I also mentioned that the other type of sequence we are going to talk about is a geometric sequence, and that is the one we are talking about today, a geometric sequence. And by definition, a geometric sequence is a sequence, so a pattern, that has a common multiplier. And for example, and I showed this the other day, here's an example of a geometric sequence. If you had 1, 2, 4, 8, 16, and then the pattern continued. So the pattern is going up through multiplication. Or let's say you had something like 64, negative 32, 16, negative 8, 4, and then it goes on. So these are other types of geometric sequences that you are going to be seeing. Not as obvious as the one before it, right? You can see this is being multiplied by 2 every single time. Well, think about what this one's being multiplied by every single time. And I want us to think about multiplication, not necessarily division. I want us to think, what is this being multiplied by each time? Now, it could so happen to be a fraction, it could so happen to be negative, but we need to think about a multiplier. And so I know that this is being multiplied by negative 1/2 every single time. So it's going to be important to identify what are we multiplying by every time in this pattern. So I say common multiplier, but we call it a common ratio, and we use the variable r in our formulas. So r is the common ratio, and that is what we're going to be using. So the common ratio, or r, is the multiplier, the number that we're multiplying by. So that's known as the common ratio. So in arithmetic sequences, you have a common difference, so it's going up or down by the same number. In geometric, you have a common ratio, which is up and down through multiplication. So like the other ones, it has a formula when we're dealing with a geometric sequence scenario. And like the others, I also want to kind of derive it and show you where it comes from. So I have this geometric sequence, 2, 10, 50, 250. And you can tell it's being multiplied by 5 every single time. So let's derive the formula. So first of all, a sub 1, the first term, is 2. So we can see that. And now I want us to think about, what do we do to the first term to get all of the next terms? Well, if I want to find the second term, I take the first term and I multiply it by 5. And not only do I want to put that we multiply it by 5, I want us to write this as we're multiplying it by 5 to the first power. You'll see why here in a second. So to find the second term, you take the first term and multiply it by 5 to the first power. Now I know to find the third term, don't write this, but technically you could say we take the second term and multiply it by 5. Right? You could say a sub 3 equals whatever the second term was times 5. But I don't want us to do it this way, because if we look at it this way, then that would mean if I wanted to find the 100th term, we would need to know the 99th term. And to find that, we would need to know the 98th term and so on. Like you can't just find the 100th term right away. So I don't want to think about it this way. I want to find the third term based on what are we doing to the first term? What are we doing to 2 to get to 50? Well, you're multiplying by 5. And then you're multiplying by 5 again. Or in other words, you're multiplying by 5 squared. So to find the third term, you take 2, the first term, and multiply it by 5 squared. And then hopefully at this point you can kind of see a pattern going to develop. So if I want to find the fourth term, 250, I take the first term and I multiply it by 5 to the third. I'm multiplying it by, essentially I'm multiplying 2 by 125 to get 250. Well, and that leads us to our formula. If I want to find the nth term, then I take whatever the first term is, in this case 2, times, well, notice the relationship between the subscript and the exponent. Notice the exponent is 1 less than the subscript. So if I want to multiply by 5 to some power, well, the power is 1 less than the subscript. So it'd be 5 to the n minus 1. And that leads us to our generic geometric sequence formula. If we want to find a term in a geometric sequence, it's a sub n equals the first term times whatever our common ratio is. So like in this one up here, our ratio is 5 to the n minus 1 power. There's our formula for a geometric sequence. If I want to find, the fifth term, I take the first term times the ratio to the fourth power. And on your quizzes and on your test, like I said, I'm going to give you these formulas. You just have to know when and how to use them. All right. Next, find the first 4 terms of a geometric sequence where the first term is -3 and the ratio is -4. So I've mentioned in this chapter that sometimes the formulas don't help you. Sometimes they make your life harder. If I want to find the first 4 terms of this sequence, and I know the first term, and I know what I'm multiplying by each time, well, just multiply by -4 each time. The first one's -3. The second one is whatever -3 times -4 is, so 12. Multiply by -4 again. And multiply by -4 again, and we get positive 192. So the formula would have caused us to do a whole lot of unnecessary work. All right. Example 2, find the 6th term if you know the first term is 25 and the common ratio is 1/5. Well, technically what you could do is write 25 and then find the second term and third term and list them all out till you get the 6th term and then circle it. Yes, you could do that if you're looking for a number that's small enough in the sequence. And I wouldn't count you wrong because you're not doing any bad math. I'm going to use the formula because I could just as easily say find the 600th term of this sequence, and you're not going to want to list out 600 terms. So I'm going to use the formula. A sub n equals a sub 1 times r to the n minus 1. And I need to think about what I can fill in and what I'm trying to find. So I'm looking for the 6th term. I'm looking for a sub 6. I know the first term's 25. I know r is 1/5, so times 1/5. And then if n is 6, then n minus 1 is going to be 5. Now, I don't really want you to use decimals, and so we're going to work with fractions as much as possible, which I love. I know you guys love to hear that. So this is the same as 25 times, well, this would be 1 to the 5th over 5 to the 5th. So 1 over whatever 5 to the 5th is, and that's going to be 3,125. And then I'm just going to reduce that, and I get 1 over 125 as my 6th term. And I didn't just know that, I just used my calculator there. All right. Find the 10th term in the sequence. We have 1/2, 1/4, 1/8. Find the 10th term. So it's very similar to the previous one, but here notice we know the first term is 1/2. They don't tell us what r is. So we have to think about what the r value is. When we did arithmetic sequences, I said you can always find the difference by subtracting 2 of the terms, as long as they were next to each other. If we want to find r, if we want to find the r term, or the r value I should say, you take any 2 consecutive terms and divide them. You just have to make sure that you do the second one divided by the first one, or the third one divided by the second one. Make sure you take the next one divided by the one before it. So if I want to find r, I could do 1/4 divided by 1/2. But you never divide by fractions, you multiply by the reciprocal. So times 2 over 1. And that gets us 1/2. Now, so if you can look at it and you know what r is, you don't have to do this math. I'm only showing you if you get to one where it's not easily seen, then you can always take the second one divided by the first one, or divide 2 of the consecutive terms. So r is 1/2. So now I'm looking for the 10th term. I know the first term is 1/2. I know the ratio. I always put the ratio in parentheses. The ratio is 1/2. And I'm going to raise that to the n minus 1, so to the 9th power. And again, I don't really want to use decimals, so I'm going to have 1/2 times 1 over 2 to the 9th. which is 1 over 512, which is 1 over 1024. So the 10th term in that sequence, you can kind of see what's happening. That the top is staying 1, the denominator is multiplying by 2 each time, and so you can see that, yeah, it looks like a messy number, but that's where we're going to end up. There we go. All right, 4. Find the second term in a geometric sequence whose 4th and 5th terms are 7/2 and -7/6 respectively. So what this means is here's the 4th term, here's the 5th term, I want to find the second term. So visually, here's what's happening. We have some first term, second term, third term, and now we know the 4th one is 7/2, and we know the 5th one is -7/6. I tend to think through I like to problem solve, and so I tend to think, how could I get this answer if I didn't know a formula? Like, would that be easier? I mean, there's various ways to go about this. I don't know R, and so generally with geometric sequences, if you don't know R, that's probably the thing you want to find first. So remember, to find R, we need to take any 2 consecutive terms and divide them. So R is going to be -7/6 divided by 7/2. Divided by 7/2. But again, I don't want to divide by fractions. We multiply by reciprocals. So times 2 over 7. 7's cancel. And we get -1/3. So that's R. So now think about this. That means that from the first term, to the second term, to the third term, to the 4th, to the 5th, we're multiplying by -1/3 every single time. So whatever this number is, I'd multiply by -1/3 to get here, times -1/3 to get here, times -1/3 to get here. What that also means is to go backwards, divide by -1/3. If I want to find the second term, just go backwards. Take 7/2, divide it by -1/3. Take whatever that is, divide it by -1/3. But remember, dividing by -1/3 is the same as multiplying by -3. So if I want to go backwards, I can just multiply by -3 as I go back. So this would be -21/2. And if I wanted to go back one more time, divide or multiply by -3, you get +63/2. Now, some people say, well, what if I don't want to do it that way? What if I want to use a formula to find the second term? Well, here's what I would do. We don't know the first term, and so what I can do is this. I know the last term is -7/6. I don't know the first term. I don't know it. I don't know this one right here. So a sub 1. I know the ratio is -1/3. And altogether, I know there's 1, 2, 3, 4, 5 terms. So 5 minus 1 would be to the 4th power. I could solve this for the first term. And then whatever I get, just multiply by -1/3. So that is an option to where you can use the formula, but that's going to be completely up to you. All right, last one. Kind of a tricky one, not really. It can trick some people, but it's very similar to that race car problem we did with arithmetic sequences in the first lesson, where the speed kept going up. I don't know what it was, 4.8 miles per hour per second or something like that. But I would encourage you guys to pause the video and try this one out and just see what answer you get, and then play it to see that if you've done it correctly. So go ahead and pause it, try it, and then I'll come back. Okay. A very common wrong answer that students put on this problem is 44.8 degrees Fahrenheit. 44.8 is the incorrect answer. So if you got that, then you really need to pay attention. If you got 35.84, then you're in good shape. What I like to do on these time problems, when it says after so many minutes, after so many hours, I like to just extend the pattern out. I'll show you how to use a formula, but here's what I would do. I would say, okay, it starts at 70 degrees. right? That's the initial temperature. It says its temperature n hours after being placed in the freezer is 20% less than 1 hour earlier. Here's another common wrong answer that you might have gotten. Let me do this really quick. 0.56 is another common wrong answer. So I want you to think about this. If the next temperature is 20% less than this, that means that the next temperature is still 80% of what it originally was. That's like if something at the store is worth $100 and they say it's 20% off. You don't owe $20, you owe $80. The price is still 80% of what it initially was. What that means is your R is not 0.2. Your R in this problem is 0.8. So that's, I guess, another little pitfall of this problem. If it's 20% less, the next value is still 80% of what it was before. So if it's initially 70 and I want to find the next temperature, multiply this by 0.8. And I get 56. So notice, after 1 hour, it's 56 degrees. This is after 1 hour. We want after 3 hours. So after 2 hours, take 56 and multiply it by 0.8 again. You get 44.8. It started at 70. After 1 hour, it's 56. After 2 hours, it's 44.8. We want the temperature after 3 hours. So do it one more time. Multiply that by 0.8, and you get 35.84. Almost freezing. Right there. The other way to do this is notice that if we want after 3 hours, if you treat 70 as the first term, you're looking for the fourth term, not the third term. And so if you're going to use the formula, here's another thing you could do, but this is tougher for some students to do. Even though it's after 3 hours, you're looking for the fourth term. And so the first term is 70, the ratio is 0.8, and we would do to the n minus 1 power. So that's another option. All right. Go ahead and try the homework and send me an email if you guys have any questions. Good luck.